Okay. Now guys, I want to ask you a question here. I want you to consider that fluoride sample and then this sample. What do you guys notice about the size of the crystals between the fluoride and this? Exactly, you can't even see the crystals, can you? Why? They're tiny. Well, why are they tiny? Look at that. Two things that we need to consider about crystals. One, not every mineral is going to have a well-defined crystal. It's not going to pick it up. It's going to have these giant crystal structures inside it. Now, it doesn't mean that they don't have crystals. The one that we're passing around is very fine grain, almost like a dust. That actually is still a crystal. The problem is that it's a crystal on a very small scale. So we can't really see the crystalline structure. But the way I relate that is I want you to think about a goldfish in a bowl and a goldfish in a pond. Which one is going to grow larger?
The pond.
Why?
That's more room.
It's cool.
That's more room to grow.
Cool.
More exposure.
Two things. Two things that dictate the size of that fish. What are they?
Size of where they live and how much
All right.
food
So the space in which they live,
and food.
not so much the food.
Oxygen.
Guys, think more generic, not specifics. Two things that dictate the size of that goldfish. So the size of its environment, so which means the space in which it grows, and what else?
The size of itself.
Genetics.
Okay, let me ask you this. What if I took a goldfish, two goldfish, and I put them in the pond? I take out one of them after a month, and I'm like, well, that's as big as you're going to get. And I take the other one out after a couple of years. Which one's bigger? The one that's been there for a couple of years, okay? Now, so there's two things here that's really important to understand that allows crystals to grow. Crystals, just like the goldfish, they need space
And time.
and time.
That was
Those are the two things that determine the size of your goldfish. Space and time. The same thing with crystals. Space and time. So when you look at this, and you look at the fluoride crystal that's huge, and then you look at this very thin layer of pink crystals that's not getting passed around, Tanner.
I
You can
forgive
tell
you,
that those
Tanner.
pink crystals, guys, have been sandwiched between two layers of rock. They didn't have a lot of space to grow. Whereas with the fluoride, you have a large cavity in which those minerals can grow. So again, those are the two important things. Now, understanding that it needs space and time, there's two sources by which we get minerals. We can get them from magma, or we get them to form outer precipitate. So explain me how the magma would work. What is magma? Molten rock, right? So it's literally the soup of minerals, all melted down. So then how do we get crystals out of that magma? And harden it, right? Gotta let the magma cool, the minerals find themselves, and they start to grow out. That's pretty much it. You have magma, we grow out. Now, with that, we can get really small crystals, or we can get really big crystals. And you guys already told me we need space and time. So if my magma cools very rapidly, am I going to have large crystals? No. I'm going to have very small crystals. But if the magma has lots of time to cool down, we can get some very large crystals that occur. And this is typically the process in which we get geodes. So when we have a geode,
Swing.
you can literally have the outer magma. It gets cooled very rapidly and it creates a protective shell, which then insulates the inside and allows the inside to cool very slowly. So we get this as a result. How slow? I don't know. It's hard to gauge. I'll say a million years, but 100 years. Now, a lot of our minerals that we typically have in our area or in volcanic areas, they form out of this thing called solution. Where we model today, and hopefully we get to see them tomorrow, is where the crystals are going to grow out of solution. Right now, your magnesium sulfate is dissolved in that water, correct?
Correct.
What happens when that water starts to evaporate? What's going to happen with those magnesium sulfate ions? All right, let's do this. Take the pond example again. Would you rather fish when the water's high or fish when the water's low?
Low.
Why?
Because the fish on the mushroom.
The fish on those mushrooms, so therefore they're more densely populated, right? Take the ions out of magnesium sulfate. It's the same concept. I have all these ions floating around all this water. But if I reduce the amount of water, what happens to those ions? Can they evaporate with the water?
No.
So then my population of my ions becomes more dense, and then they attract, and then they bond together, and we start getting the crystals that start to form out of that. And that's how we get precipitations. They're literally basically doing that. It's almost precipitating out of the water column and creating the crystals. This crystal right here, which isn't so much a crystal, but this mineral right here, is done exactly the same way. And it's where the mineral was dissolved in hot water, hydrothermal, and it was dissolved in hot water. And as the water cooled or withdrew, then those minerals start to form on top of the rock surface. So those are your two ways. So you can either get it from cooling magma or out of precipitation from solutions.